All right, if you're a Java developer, you know this feeling. You need to get data from your database using Hibernate, but what's the right way to ask for it? Well, in this explainer, we're going to open up the Hibernate toolbox and find the perfect query tool for any job you've got. So you're deep in your code, building out a feature, and you hit that classic moment. You need to fetch some data. Now, with a powerful framework like Hibernate sitting right there between you and your database, the question isn't if you can get the data, it's how. What's the best way? The most efficient, the most maintainable, the most powerful way to write that query. And here's the thing. There's really no single right way to do it. The best way to think about it is that Hibernate gives you a whole toolbox. And inside that toolbox, you've got different tools, each one perfectly designed for a specific kind of job. Your real task as a developer is knowing which tool to grab and when. So here's our game plan. We're going to explore the main tools in our query toolbox. We'll look at native SQL, then HQL, and finally named queries. And then we'll put it all together so you know how to choose the right one every single time. First up, let's talk about the heavy-duty option in our toolbox, native SQL. You can think of this as your power tool. The one you bring out when you need maximum force and absolute precision for a special job. So what is it exactly? Well, a native query is pretty much what it sounds like. It lets you write raw, plain old SQL. We're talking the exact same language you'd use if you were talking directly to your MySQL or your Postgres or whatever database you're on. There's no translation layer. Hibernate just takes your query and passes it straight through. Okay, so when would you actually use this thing? You reach for this power tool when you need to tap into some feature that's totally unique to your database, like a special function or some kind of hyper-optimized syntax. It's also your go-to for things like stored procedures or even data definition tasks like creating a temporary table on the fly. And using it is this really direct three-step dance. First, you write your SQL statement just as a regular string. Second, you pass that string to Hibernate's createNativeQuery method. And third, you set your parameters and run it. Simple as that. And here you can see exactly what we mean. This code is pure SQL. It's referencing the student database, table, and its last name, column, directly. Hibernate takes that raw string, executes it, and then does the handiwork of mapping the results back into your Java student objects. Okay, let's move to our next tool. Now, if native SQL is the specialized power tool, then HQL, or Hibernate Query Language, is your versatile, all-around screwdriver. This is the one you're going to find yourself using for most of your day-to-day tasks. Now, HQL represents a major shift in how you think. Instead of writing queries against database tables and columns, you write them against your Java objects, your entities, and their properties. It looks a whole lot like SQL for sure, but underneath, it's fundamentally object-oriented. The biggest advantage of HQL, its killer feature, is database independence. You write your HQL query once, and then Hibernate does the hard work of translating it into the correct SQL dialect for whatever database you happen to be running on. This portability is exactly why HQL is, by far, the most common way to query in Hibernate. The process for using HQL feels almost identical to native SQL. You write a string, you create a query, but this time using session.createQuery, and then you execute it. The really critical difference, though, is what you're writing in that first step. Now, look closely at this query here. We're not talking about a database table. We're saying from student S. That S is an alias for the student Java class. And then where s.lastname, that's the last name property of that class. It's a subtle change from the native query, but it is a really powerful object-oriented distinction. All right, our last tool in the toolbox isn't really a new way of writing queries, but it's a brilliant way of organizing them. Let's meet named queries. This is the tool you're going to use for all those jobs you have to do over and over and over again. So a named query is simply an HQL or even a native SQL query that you define in one central place and give a unique name to. Then, anywhere else in your application, you can execute that query just by calling its name. instead of having to rewrite the whole query string every time.
The benefits you get from this are huge. Your code gets way cleaner because you're separating the query definitions from your business logic. Maintenance becomes a breeze, since if you need to update a query, you only have to do it in one place. And you even get a nice little performance boost, because Hibernate parses the query just once when the application starts up, not every single time it runs.
And this pattern right here is just so powerful. Look on the left. You define the query one time, in this case with an annotation, right on the student entity itself. You give it a clear, obvious name like student.findByEmail. Then, over on the right, anywhere else in your code, you just call that name to run it. It's clean, it's safe, and it is perfectly reusable. Okay, so we've seen the power tool, the all-rounder, and the organizer. So how do you choose? Let's pull this all together into the ultimate cheat sheet so you know exactly which tool to grab from your toolbox, no matter the situation. And here it is, our entire toolbox at a glance. It's pretty straightforward, right? If you need database-specific features or you're calling a stored procedure, you grab native SQL. For most of your standard portable entity queries, HQL is your best friend. And for any query you find yourself using often, you should wrap it in a names query to get that boost in performance and maintainability. And that's your guide to the Hibernate Query Toolbox. By really understanding the strengths of each of these tools, you can start writing code that's cleaner, more powerful, and way easier to maintain. So, I guess the only question left is, on your next project, which tool are you going to reach for first? Thanks for joining me.